So hello and welcome from my side. My name is Markus Ritter, and in the next 15 to 20 minutes I want to show you how easy it is to program such a part. What we can see here, like a medical part, a spoon with a rasp here on the other side. How easy it is to program such a part with SolidCAM. Due to the time window that we have available, this part is already programmed. So I will guide you through all the stuff what we have here in SolidCAM. First of all, we had our setup where we can define and also visualize the part position in the main spindle. We have here 250 millimeter stroke on the Z1 axis. Here for the Z1 axis we need approximately 150 millimeters to machine the part. And on the back spindle we had defined 20 millimeter projection length out of the sub spindle here. This will be used later for the part pickup. Yeah, then let me open our new toolkit, which is introduced with SolidCAM 2021. We can define and also we can see here some ISCAR Pico turning tools, full 3D models for ID turning, ID grooving, ID threading operations. We have here also a small boring bar, 4 millimeter in diameter, with its related insert, also full 3D model. We had for this part a multi-master engraving tool here, and also for the turning operations V-shaped insert turning tool, also full 3D model. And on the B-axis we have also another multi-master tool for face milling, also full 3D model. And let's mention this tool also, another multi-master milling tool with indexable inserts, 8 millimeter in diameter, so really small. The best or a new option in SolidCAM, especially for Swiss type machining, is here for turning jobs, break material corner on stock. Let me simulate this. Here we can say we can define a size and an angle to break the material corner, especially for Swiss type machines, very useful. Sometimes you will get a burr here, and if we retract the bar into the guide bush, then this burr will be pushed away, and this is not so good for the carbide of the guide bush. So therefore we have here this option to break this corner and remove this burr, especially for Swiss type machines. Then of course we can also use balanced rough operation. Here we have selected balance mode synchronous with a distance of 1.5 millimeter and 0.2 millimeter for the slave tool. We can see it here, the master tool, and the slave tool is here above the master tool and in front of the master tool. And we can also use balanced rough operation on the D25 here, because we have two tools. Then we had some regular turning operations here, also another balanced rough operation. So we divided this portion here of the part into two sections. We don't want to retract the bar or pull the bar out of the guide bush. We have some 2.5D milling operations here to flatten these areas here from the spoon side and also from the rasp side. And then we had here our program RASP section. So, and what I can show you here is how easy it is to select the geometry and program this. So we have here a 2.5D profile operation. In the geometry page we can say new, and then we select the curve and the next curve and the next curve and so on, but this is very time consuming. We can also use the option add selected element, which is bind to the hotkey F6, and therefore we can select all these curves just by clicking the start curve and then go through them with F6. So we don't need sketches or something like that. And after we selected all that, we can go to we select our tool, of course, 3mm end mill. We have here variable levels now, and there is no need to select all the depth for all these chains. We can just do a right click and say auto detect for all, and all depths will be detected automatically. And we say OK and save and calculate, and we had our tool paths. So this geometry is symmetrical here, so there is no need to make an additional operation and select the other curves here. We just can say here in SolidCAM we use the mirror function, and we can mirror this operation, mirror about a selected plane, select the plane here, it's the right plane, mirror it about the right plane, and then SolidCAM will copy the job, mirror the toolpath, and we get here our desired toolpath. And of course we can also use in mill turn, and also for Swiss type machine we can use every milling operation what is available inside SolidCAM, 2.5D, 3D operation. So we can see here we have a 3D eye machining operation here. The geometry is our complete target. The working area is restricted to this spoon area here. So we just want to machine this spoon area. And in the eye machining wizard, we can choose our machining level. And if we calculate the operation, then we get our roughing toolpath. We have also here another 3D milling operation, HSR milling operation for the rest material or the remaining stock, where the 3mm end mill from 3D eye machining for the areas where the tool cannot go inside. So for that we use an HSR operation, and for finishing this spoon area we are using an HSS operation technology parallel to curves. Our geometry, our drive surfaces are the surfaces inside from the spoon here, and our edge curve is here, our edge curve here on the top. And under the toolpath parameters we have a maximum step over of 0.7mm, and for sorting the cutting method we use spiral. So if we simulate this in our SolidCAM simulator, then we can see that we're starting in the inside and going with a spiral toolpath from the inside to the outside to finish this portion of the part. Then after all that milling, we have here two independent turning operation. The first operation will perform a single semi-finishing cut, and the second operation will do the finishing cut on this part of the on this section of the part here. And these two operations will then be later synchronized with each other in the channel synchronization. For the faces here, we are using a profile operation, just a straight line to get the best, the shortest machining time. We have just one single line, down, up, one finishing cut, and then the next. And then we transformed it around because there's no need to make 3 jobs for each phase. We can just make one operation here, and then we say, okay, transform this operation around the 4th axis 2 additional times. And what's also worth to mention is here how easy it is in SolidCAM if you have such engraving stuff here on the part. You can use the 2D engraving, and it's very easy to select the geometry here. Even if it's wrapped on the part, you just say new, choose geometry type, wrapped. The geometry is wrapped around the Z-axis. As we can see here, it's wrapped around the Z-axis. And then we choose multi-chain, and instead of selecting all the curves, we just click into the faces. Here and the E. Say OK, and SolidCAM will generate all the chains for the specific faces here. Yeah, and of course, the selection of such geometry is also for the other engravings also easy. Then we come to the part transfer. Here we have our machine control operations, technologies. There are several predefined technologies. For instance, pre-positioning for part cutoff here. We can also visualize it in the machine preview. Here we have our Z position for the cutoff, for the pre-positioning. We can input it, we can select it from the model. We have an additional MCO machine control operation for the part pickup with a sub-spindle. Here, pre-positioning 50 mm in front of the part, and then go to our part pickup position. If we look from underneath the machine, we have here our setup location, which we define what is defined in the setup, our 20 mm. Yeah, then we had our cutoff here, and also on the back spindle some small operations. If you simulate this here, just drilling, and then with the ISCAR Pico tools, a little bit of turning and then threading. Yeah, and after we had programmed all the whole part, we can go into our channel synchronization here. And here we see we have a 3-channel machine. So the Citizen D25 is a 3-channel machine. we can synchronize here our operations. So let me show it. I just delete the synchronization, reorder it. Now we have the order of the CAM3. So this means each operation will come after the other operation. And for a nicer or a better synchronization, we can tell SolidCAM, hey, with this operation for you here, starts a new machining on the back spindle. So therefore we can move, drag and drop here these operations and say, okay, we want to do this machining, these operations, we want this in the same time as we do the operations on the main spindle. And then we synchronize these two independent turning operations, so we get superimposed control. We can also synchronize these two operations. We can also add manually sync labels. Say we have here the axis pattern G750 for the Citizen machine, and after that we cancel all that with G711. Yeah, and after the channel synchronization, after when we had all synchronized all our operations in the order what we want, we can simulate this also in our machine simulation. So we can start the machine simulation, and the machine simulation here in SolidCAM is the only integrated simulation which will simulate the synchronized operations, or let's say the channel synchronization order will be simulated in the machine simulation. The other simulations, Solid Verify, Host Cut, Turning, will just simulate the order of the CAM3. Yeah, now machine simulation data will be prepared. This takes a little bit because all the data, all the movements, what we have in the operations will be prepared and will be sent to the machine simulation. Also the tools, the 3D data, and so on. So now you should see our machine here. Now the jobs will be loaded. And now here we see the jobs, and we were waiting for the tools. Now the tools are loaded, and now we can run our machine simulation. And we have here our a nice machine simulation with a full 3D model from Citizen. Let's hide that. We can start this the simulation. We see our turning, our drilling with the back spindle, then the turning with the Pico tools. Let me pause it and let me go forward where it's interesting, because here nothing special has happened, just a little bit turning. The interesting stuff will be done on the main spindle. So here we have face operation, then our synchronous balance rough. Let's speed that a little bit up. Finishing another synchronous balance rough. Then here comes our Multimaster 8mm end mill. The other side. Then let's pause it. We have here the milling of our rasp section with inclined B-axis. Also the mirrored operation for that. Then we have our 3D eye machining operation here simulated. And let's rotate it again to view. Then our HSR rest roughing, our HSS finishing operation here with spiral motion, and then we had our superimposed operations here. As you can see, the Z2 axis of the machine is now superimposed to the Z1 axis. Let's speed it up. Our face milling here, and then the engraving of the SolidCAM, and also the engraving or the cylindrical engraving here. Then Citizen, and also for the third phase, or on the third phase, the ISCAR engraving. And after the engraving, we have here our part pickup and part cutoff. Back spindle, travel over the part, doing the cutoff. Yeah, and with that, we are at the end of the presentation. We have prepared a video of the machining, and if you have any questions or need information, then don't hesitate to contact us. Thank you, and yeah, here.
Markus, thank you very much. So Markus, please start the recording. Jonas and Adlan, feel free to talk about the tool and the machines in this video. The stage is yours.
Thank you. Jonas, you start.
Yeah, you see the first application, which is the isotherm application. Here you can see a chip former, which is actually developed only for the medical industry. For example, the cobalt chrome machining, and also high alloyed stainless steels.
Yeah, we can see here now the superimposed turning with two tools together. So at the moment only one, but in the same position we are using the same feed rate on both gang tool posts, but we will have a good example when using the second Z-axis of the gang tool number 2 to machine with two different feed rates. So we are seeing the same position. You can see that in the left side, the gang tool number 2 has also drilling process or inside turning process for the back side. Also now this is the B-axis for cross machining or cross milling. We can also use the B-axis for the back machining.
On the back side, you see also the Pico Ace in action. You see the threading operation now.
So we have on the back side possibility to integrate rotary tools or fixed tooling for turning and milling, thanks to the Y-axis on the back side. Yeah. Maybe in this stage also important to mention that we are working now the machine as a Swiss type with a guide bush. We can see the material is sliding. We can also modify the D25 to a fixed head. It means we will take the guide bush out and work with the main spindle directly in the work area. The benefits basically two: we can reduce the remnant part. It means this is also money. If you are producing from expensive material, you can reduce the rest of the bar to the minimum. And the next benefit is you can use material with less quality, with H11 for example. Okay, this is now cross machining from the gang tool post number 2. So now the B axis for the finishing, right? I think this is the tool for the finishing now.
The ball nose, ball nose tool, ball nose milling tool. And after that we should see the engraving, or no, it's the
simultaneous turning with two different cutting conditions, let's say. Now, okay. Now this is the benefit of the Z-axis. We can also use it by milling in different positions. We can use it now turning with different feed rates. We have really 60 millimeter on the second gang tool post, and this makes the machine very, very flexible.
Here you can see also a multi-master milling system. Multi-master is a modular system that allows you to clamp only one shaft or one shaft, and put on the head different milling tools or drilling tools or engraving tools.
In general, about D25, we have two types of D25, type 7 and 8. What we have now is type 8 with the servo controlled B-axis. And this is only different to type 7. Type 7, we will have cross-rotary tools on the gang tool post 1 instead of the B-axis. But type 8 is a high-end category in the D25 sector. And also maybe interesting to know that we have also a kit to increase the bar capacity to 32 millimeter. We can exchange the chuck sleeve and nut on the main spindle, back spindle, and the guide bush from 25 to 32.
Here you can see also the engraving operation with the multi-master tool. And after that, the parting off application with a special design tool for the Swiss-type machining that allows you to unclamp and clamp the insert without changing the complete tool.
So, cycle end.
Perfect. Adlen, Jonas, thank you very much for joining us today. It was an absolute pleasure.
Thank you very much.
Thank you.
Welcome. So I think it became more clear that even a complex machine can control easily with the right tool and the right software. I wish all of you enjoyed it and all of you have a successful day. Stay healthy and bye.
Thank you very much. Bye.
Thank you. Bye-bye.